Good morning, friends, and welcome back to the online learning platform at Department of Civil Engineering, BMS Institute of Technology and Management, Bangalore. I'm Rajesh Gopinath, and you're along with me for the course on occupational health and safety. If you recollect, in the previous session, we had an understanding about the development of fire. Through the help of fire curves, we were able to understand the various stages, such as the incipient stage, which is basically also called as pre-ignition. Then you have the ignition stage, which is also called as the growth stage. And then, of course, we moved on to the flashover, and then the fully developed fire, and finally decay or extinction. And what you would probably recollect is that among all these phases, flashover is the most critical phase, because once the flashover has taken place, then it is not just the safety of the occupant which is at risk, but also of the firefighting team and the entire infrastructure itself. So with this brief recap, let us continue. Today's presentation will try to understand about fire and alarm systems. Basically, we are talking in the context of early detection. So I'll explain to you the objectives, the significance, and the various systems will be briefly introduced before I summarize and list the references for your kind perusal. Friends, if you remember, we so far have a very good understanding of classification of fire. We also have an understanding of classification of fire extinguishers. But it is very important that you realize that when it comes to managing a fire, okay, there are corrective measures, there are preventive measures. Now, predominantly what you see on the screen here is a corrective measure. That is, once the fire has started, and probably it could be at any stage of its development, that we need to bring this handy. Now, that's of course important, but we also need to focus upon preventive measures. If we are unable to prevent a fire from starting, as as I told you, it is very impossible to have an environment where you do not have any combustible materials. Even if you look into your room right now, you will definitely find a potential fire load. It may be long, it may be lesser duration, it may be of huge quantity or lesser quantity, but yes, there is no way we can live without any combustible materials, probably for our standard of living, for our convenience, and so forth. So, in the event that we are unable to prevent a fire from starting, okay, at least we should be able to understand how to prevent the fire from developing or becoming a severe fire. Okay, in that context, we shall understand about today's session. And now, why are we learning all this? Because, as you know, safety of an occupant, safety of an employee, safety of an employer, safety of the infrastructure is a prime concern, because all of these are connected to productivity, prosperity, and economic growth of any nation. So it is very important that we always identify any potential fire threat, fire risk, and we can ensure it doesn't happen, okay, leading to loss of life and properties. Now, with this brief significance, now let's start today's presentation. So friends, when you basically speak about early detection system, what is the basic objective of having them in place? Why do you have alarm bells? Why do you have fire doors? Why do you have a fire department? The basic objective of your fire detection and alarm system can be probably categorized into four steps. Primarily the major objective is to always identify a developing fire. Now this identification of the fire which is developed, it can be manually or it can be via automatic methods. Secondly, the objective is to alert the occupants, to alert the employees. So whoever is a building occupant, they have to be alerted about this fire condition and they have to evacuate. Now the third objective is to notify the fire department or any emergency response organization. Now this transmission will be understood today with more details. And finally, shutdown. Please understand that we need to shut down any electrical or any special processes, any operations, or even any air handling equipments. So basically the fourth objective of your early detection system is to initiate automatic suppression systems. Okay, so these are the four objectives. Let's quickly recap. First, we need to, the objective is to identify a fire which has developed. Secondly, the objective is to alert the occupants in the building about a fire condition. So by alerting, they get the message that they need to evacuate. Thirdly, a notification or a transmission should be sent to an emergency response system or a fire department about a fire which has broken out. Finally, it's about shutting down. It's about shutting down all the operations and processes. And why so? So that the damage do not enhance. Friends, when you talk about your early detection system, basically there are three components: the control panel, the fire detection, and the fire sprinklers. Let's understand each of them further. Now, when you say control panel, just like in our human body, we have a brain, and this brain controls the functions of all our body parts, all our body organs, all our actions and reactions. Okay, similarly, when it comes to your fire detection system, your early detection system, control panel is the brain of it. Control panel is responsible for monitoring all the input devices that we may have kept. Now, it could be manually, it could be automatically. Okay, the control panel is also responsible for activating the output devices. So when I say output devices, probably bells, horns, okay, maybe emergency telephone dialers, maybe warning light, okay, and so forth. Now, when it comes to your control panel, there are two kind of arrangements in the present world. One is a traditional system, which is also called conventional, and the other one is the latest system, which is called addressable. Let us try to understand these. Friends, when you speak about your conventional system, okay, as I told you, it is traditional because it has been existing for a long time. Okay, this system is also called as point wired fire detection system. This system has been existing for several years. In fact, this has been the most standard technique or standard method, okay, for providing emergency signaling. Now, basically what happens in your conventional system, as you can see on your screen, okay, it basically involves multiple circuits. There would be one or more circuits, and these circuits are routed throughout your entire building or your protected space. Typically what happens in the system is all the alarms which are initiated, okay, or the signaling, that is transmission or notification, they are all accomplished by the hardware of the system. And what is this hardware? It is a multiple set of wires, okay, several relays. When I say relays, that is various closing and opening relays. Of course, you're talking about semiconductors, you're talking about diodes. Now, this traditional point wired conventional system also has several merits and demerits. Now, as you can see on the screen, this system is pretty simple. Okay, they are very simple. In fact, if you have a kind of a construction, probably let us say small buildings, or let us say intermediate size buildings, in those kind of buildings, this system is much more simpler to implement. Please understand, these kind of systems do not require any specialized training. Okay, you do not have to provide any large amount or a vast amount of specialized training. However, having said this, okay, when it comes to larger buildings, there is a disadvantage, because when it comes to larger buildings, if you want to install the conventional system, it becomes pretty expensive. And why is that? Because you need to have huge extensive quantity of wires, and these wires have to be monitored. So eventually time is consumed, money is consumed, and it becomes labor intensive. Okay, nevertheless, it is much more simpler, okay, when it comes to smaller buildings and intermediate buildings. Now let's try to understand the latest system in place, that is your addressable or intelligent systems. Now friends, this is the current state of art in your fire detection, that is in the present world. When you speak about artificial intelligence, when you speak about automated sensors, this system what you're looking at on your screen is a current state of the art infrastructure. Now, unlike your conventional system, that is your previous system, the traditional system, unlike that, these systems are also capable, okay, of monitoring and controlling the abilities of your alarm and signaling devices. That is, this system has much more control and provision to monitor the capability of the components. Now, having said this, it also has advantages, it also has disadvantages. Now, one of the major advantages, or let us say, if I want to put it across as advancement of this system, that is the system offering these advantages, it is specifically able to identify where a fault has developed. Now, this is a big advantage when compared to your traditional system, okay, wherein you will not be able to recognize it and you have to individually go through each connection, each wiring. But here the system will automatically tell you, okay, if there is any fault which has been developed along any wires, and it will tell you the location where this problem has arisen. Therefore, basically what I'm trying to tell you is, when there is a very fast identification of a fault, eventually there is a faster diagnosis. Okay, so whatever trouble has arisen, okay, the diagnosis will be faster and the troubleshooting will be much more efficient. Now, having said this, this technology also has certain disadvantages. Unlike your traditional system, which does not require any special training, this system you need to provide training to the technicians. Please remember that, okay? The service technicians must be trained for the respective systems. In other words, no ordinary employee or layman or even supervisor can operate this unless they have been specifically and specially trained. Basically, this training is based on the manufacturer's configuration, that is with respect to the time schedule, the number of days. It all depends on the manufacturer, it all depends on the configuration, it all depends on the requirement. Typically, a training of this kind of system you see on the screen may require at least 3 to 4 days. Okay, now that is one disadvantage of this system. Now, secondly, please understand, it is not sufficient that you just provide training. You need to make sure that you have to provide regular periodic trainings. Now, why is this? We are very much aware that when threats can improvise itself. Friends, you know very well, we are in the era of COVID-19, and you know very well how the coronavirus has mutated itself and new strains have arrived. So when the threats are, improvising themselves, even the control measures have to improvise themselves. Therefore, when any updates are there, when any improvisation happen in the system, then again training has to be provided to those personnel. Now, apart from having said this, please understand that these kind of systems have the unique operating characteristics. So you cannot generalize them. So any kind of fire detection system, depending on the manufacturer, it may vary from shop to shop, industry to industry. So that is one more disadvantage. In other words, whatever is provided to you, that is what you will be able to understand, and that is what you will be able to operate upon. Now, having said this, please understand the best aspect or attribute of this system is, if, let us say, in your intelligent system, any detector becomes dirty, probably, over a period of time due to accumulation of dust, or let us say any gas gets deposited. Now, the microprocessor which is inbuilt in the system, it will be able to understand that the potential or the capability has reduced, and having recognized it, it will send out an alert. This alert is, in other words, a maintenance alert saying that there is a fault in one of the systems and that has to be rectified. That remains the biggest advantage of this system. Please remember, a faster diagnosis will always help in better troubleshooting, and it can prevent any hazards. Now let's continue. Now let's move on to the next part of your early detection system. I'm basically talking about fire detectors. Now friends, in the olden days, who detected the fire when you didn't have the technology? It was the human beings, okay? We are actually excellent fire detectors. Now why is that? we have various senses, and one sense among them can smell, the other sense among them can sight things. All right, so yes, we are very good detectors when it comes to fire, but then please understand that our presence is required every time in the event a fire is about to break out or has broken. Now, yes, if the fire has developed, we can see it in the form of flames, or if the fire has not developed as a flame, but it is the incipient stage. If we are lucky, if there is an odor, then we can smell it and we can sense that something is wrong. But please understand, we have to be present if we have to be very good detectors. Now, not just that, okay, please understand that what if we are not present? So if a human being is not present, then the fire will develop, okay, its development will go unnoticed, and hence then the human beings would not suffice to be a very good detector. Now, having said that, now there is a need to replace the human beings with a artificial detector, some kind of mechanism, some kind of operation which can substitute the presence or absence of a human being. So in this context, friends, we have something called as manual alarm activation. So what you see on the screen is the same. But please understand, even if I say manual alarm activation, it still requires the presence of a human being. Okay, so moving on from the traditional days wherein a human being can see a fire and shout a warning to everyone in the house or in the building, and come with the buckets of water and pour the water, we have moved one step ahead, and that is manual alarm activation. Herein, when the person sees the fire, he will press the button, okay, and that will send a signal to all the occupants, probably an output device like a chime, like a bell, okay. But again, let me tell you, whether it is a traditional way of shouting out or it is a way of pressing the button in your manual alarm, both of them requires human beings. So both these systems again will not suffice if the humans are absent from the location where the fire has developed. So in this context, the new development is automatic detectors. Okay, now when I say automatic detectors, friends, basically what the detectors do is they're actually, imitating. It is a very simple imitation of our senses, the senses which humans possess, that is touch, smell, or see. Okay, so automatic detectors are basically performing the same function, utilizing the same three sensory receptions of seeing things, of smelling things, and of sensing things. Now, in this context, the oldest detector which has been in place are the thermal detectors. Now, thermal detectors are very similar to us. Okay, now it is similar because it has the ability to identify high temperatures. Okay, it can detect smoke and so forth. Now, having said this, your thermal detectors, which are the oldest type of automatic detectors, they have originated way back in 1800s. So having said this statement, you should be very clear that the significance of the threat of fire and to prevent a fire, this concept has been there since the civilization has started. So in the mid 1800s, thermal detectors came into place, and let me tell you, this system is also existing till today. Okay, now having said that, when it comes to these kind of thermal detectors, the most common units, okay, the most common units are some temperature devices, and these temperature devices are fixed on your wall in your room. Okay, now in simple words, when I have a temperature device which has been fixed on your wall inside your house, inside your room, okay, let us say the ambient temperature, that is your room temperature, if it goes beyond a certain value, so when it goes beyond a certain value, then this system will automatically send out a signal, okay, maybe a warning bell. That is how thermal detectors work. Now let's move on further to understand certain advancements. Friends, what you're looking at on your screen, probably you have seen these kind of images, these kind of fixtures in many buildings, okay, hotels and other places of importance. Now what you're looking at is basically, in other words, a very common type of thermal sensor. It is pretty common. Okay. Now this is called as the rate of rise detector, as you can see it on the screen. Now please understand, rate of rise. Okay. In other words, my dear friends, this detector that you see, it is capable of identification of any temperature which abnormally is climbing. Now we need to go back to our graph. We need to go back to the development of fire. You remember pre-ignition, ignition, flashover, fully developed, decay. Now, again, I had taught you one more graph when it comes to severity of the fire. Remember normal fire, major fire, severe fire. So, if in case the temperature is abnormally rising, then these detectors are better equipped. So, if in case the fire has happened in a building and within a short period of time, if your temperature starts shooting up, starts rising up, then these detectors are meant to provide information with respect to notification. All right, now let's move further. Now the second one is your fixed temperature line detector. Now as you can see on the screen, it looks pretty similar to your previous installation. So how different is this? Now friends, basically when it comes to your fixed temperature line type detector, now they usually contain two cables. You can see it on the screen also. Okay, they would be containing two cables, and of course there will be an insulated sheeting, okay, which is designed to break down when exposed to heat. In other words, what happens is when the temperature rises, as you know, heat is a major component of your fire triangle. Heat is a major component of fire tetrahedron. So when the heat level rises, when the temperature rises, this sheeting will break down, and the moment this breakdown happens, okay, then the unit will start providing its objective. Now, having said this, please understand these are all spot type detectors, which invariably means that you actually place them along a ceiling, or you keep it very high on a wall. Now let's move to the next one. The next one is a smoke detector. So what did we understand till now? First we spoke about control panels, wherein we spoke about the conventional system, then we spoke about the intelligent system, then we spoke about the second one, that is fire detectors. Now we are going to speak about smoke detectors. Friends, smoke detectors relatively when compared to your fire detectors are a much newer technology. If I want to put it across, it's a much newer technology, because if your thermal detectors have come into inception during the mid 1800s, your smoke detectors have come into existence. In fact, a wide usage, okay, have probably happened after we gain independence, probably somewhere in 1970s. These kind of detectors have bloomed along with the real estate. So whether it is your residential areas or it comes to your safety aspects, these detectors are much widely employed. Okay, now as the name implies, please understand these devices have been designed to identify a fire when it is in its early stages. I'll repeat the statement. Please understand, smoke detectors, you know very well that in the different stages of fire, smoke is also released. Okay, and you also know very well that if there is a fire, there would be a smoke associated with that. Okay, now as I would repeat once again, these smoke detectors, they have been designed in such a manner that they are able to identify a fire when it is smoldering or in its early flame stages. So in other words, my dear friends, what sensory perception are we talking about? It is not sight, it is not feel, but it is smell. Okay, so it is basically the smell attribute that which is inculcated in these kind of detectors. And basically these kind of detectors, they have two components. Now one is a light transmitter and the other is a receiver. Usually what happens is, as you can see in the image, they are mounted at certain distances apart. That in other words, they are, these detectors, they are placed at some distance apart from each other. So let us say say about 100 meters. So if I have this detector, I would have one more detector of the same type placed at least 300 feet away or 100 meters apart. Okay, now basically what happens is when the smoke rises, when the smoke migrates, okay, if the smoke comes between these two components, then the transmitted light would become obstructed and the receiver would not be able to receive, the full intensity. So when there is a deflection of the light which is being transmitted, or when there is a reduction in the intensity of the light which is being transmitted, it means that there is an obstruction. And what obstruction would that be if not the smoke in itself? Okay, so in other words, I can interpret this as a smoke condition. All right, now let's move further. Now, this is one type of your smoke detector. Basically, it's a photoelectric smoke detector. The application, the example of working is same as I just previously mentioned. So as you can see here, you have a light source, okay, which releases a light beam, a coherent, okay, a light beam, and then you have a light sensor. So in the event of fire, in the event of smoke, the smoke would eventually, deflect the light. All right, and that is how the detection happens. Now this is a little more advanced when it comes to your photoelectric. Now this is your ionization smoke detectors. Again, therein if you had interfered with the path of light, here you are interfering with the ionic field which has been established. Now let's move further. What you can see here is basically a very sensitive application. This is called as air aspirating system. Friends, this is the third type of smoke detector which I am expressing to you. If you recollect, okay, in the first one was photoelectric, the second is ionization, and the third is air aspirating system. This is widely being used in many places. Having said that, this is extremely sensitive. Now basically what happens is, in this kind of device, again there are two main components, okay. One is a control unit which houses your detection chamber, that is an aspiration fan and a circuit, okay, and then you have your network of sampling tubes or pipes. So basically, if you can see here very carefully, there are perforations along these pipelines. Now this how it facilitates is, when you have perforations in these pipelines, obviously air would enter. When air enters, if there is smoke, the smoke also would enter. So whatever is entering, that sample of air is basically analyzed for existence of smoke, okay, and then eventually it is returned to the atmosphere. In other words, if you observe the movement of my cursor, okay, the air enters from this slot or perforation and it moves further. So whatever sample of air is entering, okay, there is a unit which tries to measure if there is smoke present in this air. Of course, that is one part of the system. The other part is that air is again let out back into the same environment, okay. So what is the biggest advantage of a smoke detector? The biggest advantage is it is able to identify any fire even if it is in its incipient stage, that is in its pre-ignition phase, okay. However, along with this key advantage of being able to detect fire even before it has grown, even before it has gone to ignition phase, there are certain disadvantages, okay. Now one major disadvantage of smoke detector is, they are relatively expensive. That is, they would cost much more when compared to your fire detectors, or let us say your thermal sensors, okay. Anyways, now let's move on and let's try to understand about flame detectors. Friends, this is the third major type of automatic detection system. Now, let's recap. We spoke about fire detector, we spoke about smoke detector, and now we are talking about flame detector. And let's recap. I told you that we have three basic sensory perceptions that we are trying to imitate. We are imitating the sensory perceptions of human beings. What are those sensory organs? Eyes, nose, and skin, okay. We are able to feel if something is hot, we are able to smell something in the air, and we are able to see if there is a fire. Now, if in case I put it across that your smoke detector is imitating smell, fire detector is imitating feel or touch, flame detector basically imitates sense of sight, okay, that is the human sense of seeing things. Now basically friends, these flame detectors, as you can see across on your screen, they are line of sight devices. Now having said that, they can operate either on ultraviolet or probably infrared, or maybe sometimes they also operate on a combination of infrared and ultraviolet principles. All right, now let's move further. Alarm output devices. So we have a control panel which is the brain of the entire system. Then we had detection systems, detecting flame, detecting fire, detecting smoke. So we have a brain and we have sensory organs. But now what is important? We should be able to put across the message to the society, to the community, to the occupants, to the employees, to the employer, that a fire has broken out. So whatever you have understood previously were probably input devices and like a CPU. Now let's talk about your output devices. Like in your laptop, like in your mobile phone, you have input devices, you have a central processing unit, and you have output devices. So similarly, now let's talk about the output devices in your fire detection system, because without this, how would you be able to communicate? How would you be able to notify the stakeholders? And if you do not notify or communicate, then the entire purpose has collapsed. So friends, as you can see on the screen, there are various output devices. You've got bells, which is of course the most common and familiar alarm sounding device. In fact, these are highly appropriate for most of the building applications. Now, apart from bells, you also got horns. Okay, it's another option. But please understand that they are suited to those areas where loud signals needed. Okay, now let us say probably if there are certain architecturally sensitive buildings. Okay, now moving on from bells and horns, now we also may have chimes or chimes. Okay, now this is used wherein you have a soft alarm tone. So you can understand that as I move from bells to horns to chimes, I'm also talking about the magnitude of sound which is generated. Okay, now the amount of sound which is generated in bells, okay, is much more lesser when it comes to your horns. So probably in our own college, during one there is a shift from one class to another class at the different hourly intervals. What you hear is not a bell, it's a horn. It makes a loud sound. Okay, but then if you go into a hospital, all right, or let us say you go inside a library itself, you cannot afford to have bells and horns, because word silence is also important from safety aspects. Then you go for chimes, wherein it's a very soft alarm tone. Okay, now even your theaters, as a matter of fact, they use chimes. Okay, now finally we also have speakers, which is your fourth alarm sounding option. Now basically what it does is, if you remember, if you go to your airport, if you go to any railway station, you hear recorded messages. People who have, or people, you hear people speaking. Sometimes you hear them speaking live, real time. Sometimes you hear information from them which has been recorded. So and so train is arriving at so and so time. So basically I'm talking about the speaker system. Okay, wherein a reproducible signal, that is a recorded voice message, will be played. Now friends, please understand, these are most suited for multi-story buildings or large buildings, where evacuation, if it has to happen, it has to happen in phases, otherwise it would lead to stampede. Okay, now let's move further, and now let's try to understand about the sprinklers. Okay, your fire sprinklers. Most of us have seen the application, the representation of what you see on the screen here. You do have it, especially in hotels and big buildings. You see them connected on your walls. Sometimes you see them connected with pipelines. Now friends, we know very well that water is the most ideal extinguishing agent. We have understood this several times. Okay, now we try to take advantage of the same. Fire sprinklers, basically, they use water directly. Okay, they use the water and directly apply it onto the flames, onto the heat. That is, if there is a breakout of a fire, so how they operated, the water which is being released would directly fall, the water would be sprinkled, the water would be sprayed, the water would be splashed directly onto the fire or flames. Okay, now having said that, please understand these are most effective only in the initial phases. Okay, that is during your pre-ignition or your growth phase. At that point of time, the system is extremely effective and therefore you can control the fire. But once the flashover takes place, once the criticality has been achieved, then this system would not suffice to deliver. Now, having said this, when you speak about a sprinkler, any properly selected sprinkler, it is capable of not only detecting the heat of the fire, it is also able to initiate alarm and also begin suppression within moments. In other words, the system what you are looking at, it is capable of detecting the heat, it is capable of sending a signal, and also it is capable of suppressing the fire by applying water. So that is the basic mechanism of your fire sprinklers. Okay, now let's understand the various components of your sprinklers. Very simple. Now definitely you're talking about water, right? So just like in your if a building has caught fire and if you want to douse the fire from outside, you take help of a fire hydrant. Okay, similarly, internally speaking, you again need to store water. So yes, you would have a tank or some kind of sump which specifically stores water, and this water is not meant for drinking or cooking or washing or cleaning, but rather this water is specifically stored only for firefighting. So having a source of water, then you would need to transport the water via a series of network of pipelines. Okay, so that is the second part of it. And then of course you have your sprinkler. Now having said that, please understand a sprinkler itself will behave like a spray nozzle. That is the objective of distributing water over a defined fire hazard. Apart from this, what you basically see on your screen is a frame. It could be a metallic frame or it could be of any other make. Okay, so basically the frame is your structural component. See, as you can see here, this is the structural component of your fire sprinkler. In other words, it is that component which holds the sprinkler together. Okay, finally we also have the thermal linkage. Friends, thermal linkage is that component which will control your water release. All right, so that is by a mechanism, when the heat rises, this system is responsible for releasing water and dousing the fire. Okay, of course there are deflectors, there are caps. I would not delve more into that. What are the advantages of this system? So basically when you talk about your fire sprinklers, there are various benefits. Okay, primarily your fire sprinklers are able to immediately identify a developing fire. It is capable of immediately controlling a developing fire. Please understand that sprinkler system responds across all the times. Whether you have one person inside the house or many people inside the house, or whether there is nobody inside your house, irrespective of this, the sprinkler system will respond immediately and the control is generally instantaneous. Okay, please understand the prime objective of fire prevention is life safety, and secondly it is safety of the infrastructure. So whether you have occupants or no occupants, it is able to achieve in the objectives of fire prevention. Now your fire sprinklers are also capable of alerting immediately, that is in conjunction with your building fire alarm systems. Okay, these automatic sprinkler systems, they are capable of notifying not just the occupants but also any emergency response team or any emergency response personnel with respect to this. Now, what is the advantage of having fire sprinklers? You will be able to avoid any damage, okay, which is happening due to the heat and due to smoke. Both of these are well associated with your fire. Okay, please understand. This is a very important statement because significantly less heat and smoke will be generated when the fire is extinguished at early stage. Okay, If you are able to douse the fire at early stage, then there is less of heat and smoke generated. Later, if you're unable to control the fire, it is the heat and smoke which causes the maximum damage. As I told you in the previous class, when there's a fire breakout, there would be very few individuals who might have been charred to death, but most of the people would have died due to inhalation of the smoke, unable to bear the rising temperature levels, because you know very well that body also has optimum temperature, and we would not be able to survive if the body temperature goes up. Okay, so what is the basic idea? The basic idea is fire sprinklers are able to enhance the safety levels of the life of the occupants of the, let us see, it could be a staff, it could be a visitor, it could be an employee, it could be a firefighter. Okay, the life expectancy, the safety is enhanced. Okay, of course, you also have design flexibility, and you have a very enhanced security system. And most importantly, having said these two terminologies, please understand, yes, you are able to decrease the expenditure or the money which you spend on insurance. Okay, please understand that the sprinkler control fires, they are less damaging than the fires in non-sprinklered buildings. Therefore, if you are applying for an insurance, okay, the insurance underwriters, they offer reduced premiums in sprinkler protected properties. So that is one more advantage of your fire sprinklers. Now let's move further. So we spoke about fire sprinkler systems. We spoke about the basic infrastructure. We spoke about the advantages. Now let's try to understand the various types. As you can see in the screen, you have different types such as the wet pipe type, dry pipe type, the pre-action, the deluge system, the in-rack system, and of course, the early suppression fast response system. In today's class, we shall be delving more into the wet pipe, the dry pipe, and of course pre-action. Friends, what you see on the screen is basically wet pipe on your left hand side, okay, connected with water, and the dry pipe on the right hand side connected with a gas. Let's understand what they are. So friends, your wet pipe systems are basically the most common sprinkler system that you can see across the globe. Okay, now what basically happens in the wet pipe system? Just look at the name, wet pipe. Okay, so as the name implies, in a wet pipe system, water is constantly maintained within the pipelines. I repeat, as the name implies, in a wet pipe system, water is constantly maintained within the system, within the pipelines. Okay, when a sprinkler gets activated, it is water which is immediately discharged onto the fire. All right, so as you can see on the screen, it would have a series of pipes. Okay, as you can see on this image, it is water which is flowing inside it. All right, now what are the advantages of it? It's pretty simple. The system itself is very simple and reliable. And why is that? Relatively compared to other systems, it has very less number of components. When you have less number of components, you have less number of components which might backfire, which might malfunction. Okay, now it's very easy to install them, and the maintenance cost is also very less. And in case if there's a need for modification or upgradation, it's pretty easy to do that. Okay, now let's move on to certain disadvantages. Friends, you're talking about water, right? So probably, in certain, colder regions or regimes, you would not be able to employ this system, because you know very well water has a tendency to freeze. Let us say you go towards countries like Bhutan or Siberia, that's in Russia. Okay, in those places, the system will not work, because during the night time, the water would have frozen in the pipeline. So in the event of a fire breakout, you won't have water dripping out. All right. So that is one of the major disadvantages of your wet pipe system. That is, it is not suited for environments or conditions with sub-zero temperature. All right. Now, also, if in case you try to employ this system in buildings such as warehouses, these pipelines may get damaged due to the existing machineries or operation of the those machineries or movement of materials, they may get damaged, and when they get damaged, they would definitely not satisfy the purpose it is built for. Now, the next one is your dry pipe sprinkler system. Friends, in this, it's pretty similar to your wet pipe system. The major difference is instead of water inside the pipeline, you would have pressurized air or, sometimes nitrogen. Okay. Now, what we need to understand is this system does not depend on water. It does not depend on storage of water. So even if you have a condition where it is sub-zero temperature, then the system is much more advantageous than your wet pipe system. The greatest advantage of your dry pipe system is no, they are capable. They are able to provide automatic protection. Okay, let us say there is a freezing condition. Even in that circumstance, they are able to protect you if the fire breaks out. But having said this, this also has certain disadvantages. When compared to a wet pipe system, this is much more complex because it's not that water is flowing in the pipes, it is pressurized air, it is nitrogen gas. Okay, so the system would be much more complicated, much more complex. Automatically, the installation cost is higher, maintenance cost is higher. Okay, and in the event of any kind of damages and repair, you don't have that much of flexibility. Okay, even if you're talking about expansion, it doesn't happen. And yes, there is a greater potential when it comes to corrosion. And when compared to your wet pipe system, the fire response time is increased. Okay, now let's go to the last one within the scope of today's presentation, and which is your pre-action system. So friends, basically, if you're looking at this kind of system, as you can see a real-time image which I've posted on your right-hand side, and of course a schematic on the left-hand side. So this third sprinkler system, which is your pre-action system, basically what it does is it employs this basic concept of a dry pipe system. Okay, only thing is, all right, that here, okay, let's try to understand this once again. All right, we have studied wet pipe system, we have studied dry pipe system. You know very well that in your wet pipe system there is water, in your dry pipe system there is pressurized air or gas. Okay, this system, my dear friends, it actually employs the basic concept of a dry pipe system. Okay, that is, there is no water contained within the pipes, but the difference is here it is water which is held from the piping by a electrically operated valve. So please understand, it is very similar to a dry pipe system, but only thing is here there is an electrically operated valve which is called pre-action valve. Okay, now the operation of this valve is controlled by an independent flame, or let us say heat or smoke detection. All right, now please understand, if this kind of system, if the sprinkler has to activate, then two separate events must happen. Okay, first the detection system must identify a developing fire. So when it identifies a developing fire, what should it do? It should open the pre-action valve. Okay, when it does that, it will allow the water to flow into the system piping. Okay, which effectively creates a wet pipe sprinkler system. Friends, in other words, in a very simple way, if I have to explain pre-action to you, remember, in a wet pipe system, there is always water flowing in the pipes. In a dry pipe system, it is pressurized air or it is gas, nitrogen gas. In pre-action system, you have to assume that it's a system of dry pipes. Okay, but that means it contains only air. Okay, I am not specifically saying pressurized air or nitrogen gas. It has air. Okay, but this dry pipe system becomes a wet pipe system because of an electrically operated valve. That remains a difference in your pre-action system. Please understand, the biggest advantage of this system is its dual action, which is required for the water release. All right, now, but yes, this system also is very costly to install. Its maintenance cost is also very high, and please understand, the reliability is not that acceptable, and sometimes to do these modifications it really requires trained personnel. Okay, the installation requires, the maintenance requires trained people. So, what did we learn today? Today we have understood about early detection of fire, the various systems which are involved in it. We spoke about the control panels, the types of control panels. We spoke about the various output devices, that is your fire alarm. We spoke about your detectors, that is your fire, flame, smoke detectors. And then we also concluded by speaking about the different type of fire sprinkler system. Okay, so friends, these are the references for a kind perusal. I would request you to look at serial number 19, which is directly connected to today's presentation, and by going through this, your knowledge will be enhanced beyond the scope of the curriculum. So friends, in the subsequent class, we shall be talking about a program, Fire Prevention and Protection Program. So the presentation is done, and now the forum is open for any questions and queries that you might have. Thank you, one and all.